Tree mortality globally has been on the rise. The data show that globally more trees are dying than they used to in the past. And we wanted to understand why and where this is happening, and can we design tools to detect this. So we're working with a couple different networks of forest research sites. So we have the Smithsonian Institution has a program called Forest Geo, which is a network of research plots around the world. And there are many of them here in the United States. And we're focusing in on 5 specifically in the United States that are in forests where we mapped and measured all of the trees bigger than a centimeter in diameter across a large area, many acres. These sites also happen to be part of the National Ecological Observatory Network, which is an NSF-sponsored program that happens in lots of places across the country. These are large research projects where they're measuring the same thing all over the place. So we have this network where we have mapped trees, and we have this network where they're measuring vegetation and trees, and they're flying it with airplanes annually. So we have 5 sites that are both Forest Geo plots and NEON sites, National Ecological Observatory Network. And we're linking those, and we're utilizing the tree measurements that are at these sites, these high resolution tree measurements, with drone flights, with high resolution remote sensing equipment where we get LiDAR, which measures heights and uses lasers to make point clouds, and hyperspectral imagery that looks outside of the red, green, blue spectrum that we can see into the ultraviolet and the infrared. So we're going to diagnose diseases, we're going to look at damages, we're going to look at causes of death or factors associated with death. From this data that we collect, all this ground truth data and remote sensing data, we're going to design tools that will allow us to hopefully detect tree mortality, but also predict. So we should be able to design tools that will detect the signals of a tree that's stressed. Our goal is to design these tools to detect early problems in forests so that then we can manage forests more easily to prevent catastrophic outbreaks and decrease the amount of tree mortality that's happening.